transducer changes one form of energy into another. There are two types of transducer. Input transducers, for example microphones and light sensors, and output transducers, for example loudspeakers and motors. Input transducers. In an electrical system, an input transducer supplies the system with electrical energy by converting a different energy source. Example: a microphone is an input transducer. It converts sound energy into electrical energy. Output transducers. Output transducers receive an electrical input and convert this to a non-electrical output. Example: a loudspeaker is an output transducer. It converts electrical energy into sound energy. Electronics in real life. Throughout this, click on the radio to see inside it. Let's take a closer look. This picture shows the speaker from our radio cassette player. It converts the electrical signal from the radio or the cassette player into the sound you hear. Transducers. Put simply, an input transducer has a non-electrical input and an electrical output. An output transducer has an electrical input and a non-electrical output. State whether the following devices are input or output transducers. Light emitting diode, LED. Select the type of transducer. You were correct. An LED is electric heater. Select the type of transducer you think you were correct. An electric heater is an output transducer. In an electric heater, the input is electrical and the output is non-electrical. Light-dependent resistor, LDR. Select the type of transducer you think an LDR is. You were correct. The resistance of an LDR decreases when it is illuminated. Strictly speaking, the output of an LDR is not electrical. However, if used in a circuit, it will change the voltage across it, and hence appear to have an electrical output. Electrical motor. Select the type of transducer you think an electrical motor is. You were correct. An electrical motor is an output transducer. In this type of motor, the input is electrical and the output is non-electrical. Electronics in real life. Throughout this CD-ROM, we will be showing examples of electronic components at work. The examples we will be using are the components of a simple portable radio. Click the Continue button to see an example of a motor used in this electronic device. Let's take a closer look. This picture shows the motor in our radio cassette player. You may have noticed an electrolytic capacitor connected in parallel with the motor. This component is used in order to keep the motor speed constant. How can we use transducers? For transducers to be any use to us in the real world, we must use them in situations where they will switch on or off depending on the conditions. Getting a device to switch on or off is sometimes referred to as achieving a high or low, high being on and low being off. Achieving a high or low. Input transducers do not just switch on or off. They vary due to whatever is affecting them at the time, heat, light, etc. Therefore, we need to add something to the transducers that will switch either on or off when a certain level is reached. That device is a transistor. In this example, we will set an LDR to switch on a lamp if it gets dark, using a transistor. Remember the characteristics of an LDR. We can see that an LDR has a large resistance when in darkness. We also know that a transistor allows current to flow through it when 0.7 volts or greater is applied to its base. Now we know all we need to build the circuit. Firstly, we know that the lamp must be off when the LDR is illuminated. Therefore, when the resistance of the LDR is low, the voltage in the transistor base is also low. This tells us the structure of the circuit. The value of R1 must be very much greater than the value of the LDR resistance. Now we will work out by how much.